This is your last PowerPoint and topic of the semester for lectures. It is experiments. You have heard of experiments pretty much in Methods 1. You still have some aspects to learn in Methods 2, namely field and natural experiments that are pretty important in social science. So we will start by answering two questions here. First question. Why are experiments so hard to conduct in social science? Experiments are pretty easy to conduct in hard sciences, natural sciences. But in social science, it's a challenge because we are experimenting on humans. We are experimenting on human behaviors. And humans are very complex beings. We're really smart, we're really creative, and we do not behave like molecules behave. We never behave the same way in the same situation. We are very subjective. Experimenters are very subjective as well. Human beings are ever changing as well. How I am today, how I will be next week, is not the same. So this makes experimentation extremely complex in social science. But experiments are very useful in social science. They're useful because with an experiment, we can safely say that A causes B. Causation can only be understood well with experimentation. By doing a survey, by doing a content analysis, by doing an observational study, you can say that A and B are correlated, but you cannot say that A causes B without doing an experiment. There are three major criteria to meet to be able to say that there is a causality between two variables. So here, x is my explanatory variable and y is my response variable. The first criteria to infer a causation, there must be a correlation. Two variables must be at least correlated if we want to say that one causes the other. Second criteria, my explanatory variable must happen before my response variable in time. If both happen at the same time, it means there is a correlation, but not necessarily a causation. Also, I have to be able to eliminate possible lurking variables that would affect y, my response variable, to be able to say that x will cause y. Example, if my explanatory variable here is the number of hours spent in a day on social media. So this is my explanatory variable. Spending more than 2 hours a day on social media. My response variable would be here in my example, having a low self-esteem. So I want to prove a causation between spending more than 2 hours a day on social media and having a low social self-esteem. Y is being affected by X causes Y. So there is a correlation between X and Y. It's been shown that spending a lot of time on social media is correlated with a low self-esteem. I'm good with my first criteria. If I do an experiment, I will be able to show that by the fact that I spend 2 hours or more on social media, then after my self-esteem will be affected. So my explanatory variable precedes my response variable. If I see that someone has already a very low self-esteem before spending a lot of time on social media, then I cannot say that social media causes low self-esteem. Third criteria, I have to rule out possible lurking variables that would affect self-esteem, but without being time spent on social media. Academic success would be maybe a lurking variable, social life, family life, romantic relationships. These things affect someone's self-esteem, but they're not social media. So when I'm conducting an experiment, I would have to choose subjects that have a similar academic success, a similar romantic situation, a similar family situation, a similar social life, then I will be able to test how social media affects self-esteem, and I will be able to say there is a causation. Now we will see three types of experiments. The first type of experiment we do in social science is called lab experiment. And you have learned what a lab experiment is in Methods 1. You know it already. You remember when you have learned randomized comparative designs, block designs? These are lab experiments. They are not necessarily done in a lab, but they're done in a controlled environment. This is what we call a lab in social science. In a lab experiment, the researcher totally controls the treatment, totally controls the explanatory variable. One example of that you might have probably discussed in Methods 1, a research question here. Does exposure to violent video games increase aggressive behavior on teenagers? I could do a lab experiment to test that. I take 100 subjects, similar subjects, and I randomly assign them into two groups of 50 students. The first group of 50 students will play Assassin's Creed during 1 hour nonstop. 50 students of my control group will play Tetris or any absolutely non-violent video game. Then I will test my 100 subjects. I will give them an identical stimuli, and then I will measure their aggressiveness in response to that stimuli. So I will compare my two groups here. This is a lab experiment. I totally controlled the treatment, the type of video game they play. I totally controlled the explanatory variable, the type of video game, and then I compared my two groups. Another example, what is the effect of cannabis on driving abilities? Same thing here. I can take 100 subjects, similar. I randomly assign them into two different groups of 50 subjects. My first 50 subjects my first group will smoke a joint. My second group will smoke nothing. And then I will ask all my subjects to take their car and to try to park the car in a parking lot in a specific spot that would be identical for everyone. And then I will compare results. Those who smoke a joint, are they able to park the car successfully? And those who do not smoke, my control group. This is another example of a lab experiment. You have learned that really well in Methods 1, so you know that kind of experiment already. There are pros and cons of doing a lab experiment. Advantages are it is much easier to control lurking variables because you control the whole environment of the experiment. So it's much easier to measure causation here. Also, these lab experiments are more valid. You remember what valid means from Methods 1? Validity means you really measure well what you have to measure. So in a lab experiment, it's easier to measure your variables because you are in total control of what's going on. But there are some disadvantages as well. It's not real life. You cannot reproduce all real life situations as they would happen in real life in a lab experiment. So in my parking lot, I control the parking lot. I won't give a joint to a student and give him a car and say, go drive in the real world. I wouldn't do that for ethical reasons, for security reasons. So I totally control what's going on in the parking lot. There is no kids running around. There is no shopping carts going around. So it's kind of easier to park your car in such a situation. So not being a real life setting will kind of affect my results a little bit. It has also a lower external validity. External validity means how am I able to apply my results to the broader world? What happens in my parking lot? Would it happen in other situations that could happen in life? Maybe not. So this is what we call a low external validity. My results are very good in the framework of my experiment, but how would I apply them to real life? There's also the Hawthorne effect. People will change their behavior when they know they're being studied. They will make more efforts. They will make efforts to look good, to perform well. So this happens in a lab experiment because people know very well they're being studied. Even if we use deception, they know they're taking part in an experiment. So this will cause a change in natural behaviors. Field experiments are different because they are conducted in real life. So you do not, as a researcher, you do not control everything. You do control the explanatory variable, which is a treatment in this kind of experiment. But you kind of have to give up some control because you do the experiment in a real life situation. You lose control, you lose a certain control on lurking variables as well, because in a real life context, things happen. You don't control everything. I will give you examples in the next slide, and you will understand really well what a field experiment done in a real life situation is. The first example of a field experiment I give to my Methods 1 students, without telling them it's a field experiment, it's the broken car experiment. Let's say I want to understand how the attractiveness of a woman will influence help behaviors in men. Are men more willing to help a woman in a situation if this woman looks good? So what I could do, I could take three different women. A young woman, a young good-looking woman, a 50-year-old random woman, and Miss America, super top model. And I will put these three women in an identical situation. Aside the street with a broken car with the hood of the car open. The hood of the car open. And then I will watch. I will hide somewhere during 2 hours and watch how many men stop to help that woman. if 30 guys stop to help my top model, Miss America, and 40 guys stop to help my good-looking young women, and only 5 guys stop to help my 50-year-old women, then I will reach conclusions. Oh, the physical aspect of the girl will influence the behavior of men. Huh? So this experiment is done in real life. It's not done in a lab. I will use a real street during any day of the week. So this is a field experiment. I give up some lurking variables. I control some other lurking variables. Of course, I will use the same car. I will not give a Tesla to my young women and a junk Toyota to my old women, because maybe the guys will stop to watch the Tesla, not the girl. So I will give the exact same car. I will use the same street during 3 different days, or a very similar street during the same hour of the day, so there is no rush hour or dead hour. I will try to control all possible lurking variables. But I do not control all possible lurking variables. The guys who drive by the car won't be the same guys for the 3 women. Maybe there will be it's a sunny day and then a different day. So not all lurking variables are controlled here. Another example of a field experiment that was done in the past is the resume experiment. I want to know if the name of a candidate will influence employers in calling this candidate for an interview. So I can send the same resume or an equivalent resume with 3 different names to a number of different companies. One with a Canadian name, one with a Latin name, and one with a Arab name. And then I will compare these 3 candidates, how phone calls or how feedback they received from potential employers. This is a real life situation. They're real companies, they're real search for candidates. But I totally control the explanatory variable here, which is the treatment, which is the name I put on the resumes. There are pros and cons as well in field experiments. Advantages are it's a higher external validity. I can apply my results better to the world because my experiment was done in real life and not in a lab. Also, people, my subjects, will never alter their behaviors because they don't know they're taking part in an experiment. The disadvantages, I mentioned them already. You have less control on your variables. You have less control on your lurking variables as well, because you do not control everything that happens in a real-life situation. The third type of experiment is called a natural experiment. It is done when the researcher does not control any of the variables, does not control the explanatory variable, the response variable, or any lurking variable. They have a question to answer. They cannot manipulate the variables because either it is impossible, not feasible, it is unethical, or very dangerous. So they take advantage of situations that happened in the past where the assignment to different variables was done anyways, by nature, by historical events, etc. And they do the study afterwards. I will give precise examples in the next slides, and you will understand really well. The 2 examples of natural experiments I will give you here are examples of treatment versus control. It means some subjects at some point in history were exposed to a treatment, to an explanatory variable against their will. It happened because of an event. And as a researcher, you can use this to study, to answer a research question. There is a study going on right now. It's called the Ice Storm Baby Study. It's a very good study to answer the following question. When the mother is exposed to a high stress during her pregnancy, does it affect the mental health of her children? There's an hypothesis that says that when a mother is exposed to a lot of stress during pregnancy, children are more susceptible of suffering from anxiety, of having learning disabilities later in life. It is impossible to do that, to answer that question with a lab experiment. I will not take 50 pregnant women and tell them, I'm putting you under extreme pressure, I'm stressing you a lot, so let's see how your baby is going to come out. It's very unethical. So I can do that by looking at a group of women that were exposed to stress in history. And it happened during the 1998 ice storm. Some women were pregnant and were really stressed because they had to live in shelters, they had no power home for a month. So this is a very stressful situation for them. And now their babies are 22 years old, so we can study them. We did not impose that on women. Life imposed that treatment on women. And we can compare these women with the same number of women that were pregnant at the same time and were really quiet and with no stress at all. So the exposure to a treatment was done, but was not imposed by the researcher. It was imposed by life. Another example of that is texting and driving. We're pretty sure that texting while driving is causing accidents. And it would be really nice to be able to test that hypothesis in a field experiment. I take 20 young adults, I give them a smartphone, and I tell them, drive to Montreal, text all the way, and let's see how many of you are going to make it alive. And then I take another 20 students and I tell them, drive to Montreal, no cell phone. We'll compare, who dies? I cannot do that. It's unethical, it's dangerous. But life did that for me. Teenagers did in the past drive while texting. So I can use that assignment to the explanatory variable that was done by life and not by myself to test, to make a research on how texting will be dangerous, will cause accident or not. So this is another example of that, of a natural experiment. Other examples of natural experiment are examples of what we call pre-event versus post-event experiments. These are other experiments that I could not do because of ethical reasons, because one example, my first example is the following. I don't know if you remember, but exactly 2 years ago, there was a young girl, a high school student, who died around Montreal because she had mixed alcohol and energy drinks. So that's a very interesting field of study to help people. Does mixing energy drink and alcohol will affect your chances of survival in a situation? Is it dangerous? So I cannot do that in a lab or in a field experiment. I cannot tell teenagers, drink a lot of alcohol, a lot of energy drinks, and let's see what's going to happen to you. I can't do that. It's unethical. But we're still able to do an experiment, because after that event, there were new laws put in place in convenience stores, in grocery stores, about the sales of these energy drinks. I don't remember what the laws were, but they're much less accessible to teenagers right now. So, pre-event, before the death of that girl, how many teenagers died because of mixing alcohol and energy drinks? And after that event, after that girl died and new laws were applied, how many teenagers will be affected by the same situation? So we can compare two groups, one before the event and one after the event, to determine if these new measures help teenagers. So the explanatory variable in this case here was imposed by this event, before the event or after the event. Another example is when there is a major social crisis, as a pandemic, for example. Will this event change the behavior of citizens? Will more citizens have prepper behaviors after a pandemic than before a pandemic? That's an interesting subject to study. So it's another pre-event versus post-event. Let's say the event here is the pandemic. I cannot possibly create that experiment in a lab or in the field. I will not create a pandemic in the population to test the behaviors of people. That's unethical, that's dangerous. So what I will do, I will compare the population before the pandemic, before pre-event, how many citizens showed prepper behaviors. And then I will compare them with the population when the crisis is over. How many citizens? What's the percentage of citizens who show prepper behaviors? Chances are more people are going to show prepper behaviors after the pandemic. So that's another example of a pre-event, post-event natural experiment. And history will tell us the result. So that's it. Oh no, we have one more slide. Natural experiments also have pros and cons. Advantages of that specific kind of experiment: you can actually make studies that would be impossible to conduct otherwise, because it's unethical, because it's very dangerous. And also, since these exposures to explanatory variables are done in real life settings, people will not alter their behaviors. They will behave normally because it's normal life. One disadvantage, a major disadvantage, is that you do not have any control on any lurking variable in such an experiment design. So now that's true. We are done with the lectures. Well, good luck for the test. And that was Methods 2 material.